This sounds familiar.
Basically, did you know formaldehyde's everywhere? I mean, that's nothing really new to some people. A lot of people don't realize that, you know, it's in the foods that we eat, in your body. It's kind of like at a steady state. We produce it. There are other things all over the world that produce formaldehyde. If you smoke a cigarette or when you crank up your car, you burn gas. So it's all around us. So there's no such thing as zero formaldehyde. So we can kind of discount that. So if anybody talks about zero formaldehyde, we can just say right off the bat that it's not possible. And you know, what are the concerns about formaldehyde? Again, this is kind of rehashing a lot of the things that we've known for many, many years and why it has been targeted as a chemical that should be eliminated from particularly the clothing that we wear is our big concern. Now, there are other things that cause the generation of formaldehyde in clothing, but to my knowledge, and I've done a lot of research, there's never been a documented case of anyone contracting cancer or even any kind of a sensitivity to formaldehyde by wearing wrinkle-resistant clothing. So, in the United States, it is a probable carcinogen. Most of the real area where it's a major concern is like embalmers that are subjected to high levels of formaldehyde. But even now, they have systems that where they embalm bodies and they don't have exposure to formaldehyde like they used to. So they have this ventilation in this system of being able to take it away from them to reduce exposure. But it has found to cause respiratory inflammation or distress, particularly in the days when we had high formaldehyde and we were doing post-cure finishing. Post-cure finishing is whenever you finish the garment rather than the fabric, because at that time the resin was not cured, and so you had this generation of formaldehyde, and the workers that were sewing the garments, and the workers that were finishing the garments and pressing the garments were subjected to the release of the formaldehyde because the resin had not been cured at that particular point. The global market for formaldehyde is estimated, you can see there, at 13.5 billion. It's in pressed wood that has received a lot of press, no pun intended there, from the exposure, particularly with the trailers that were taken down to New Orleans after Katrina. It's in paper, automotive, so you know just about everything. A lot of people didn't realize that it was in cosmetic and shampoos, and so there's a big move now to get formaldehyde and triclosan out of the cosmetics and shampoos because it's used there as a preservative. The global textile market is only 2% of that total for formaldehyde. It's used in resin manufacturing, binders, pigments, flame retardants, water stain repellents, anti-cling finish. So it's not just a cotton issue, it is a textile issue. So that's one thing that we really wanted to get across. So it's been used since the 20s. The most common use for it today, what we use for finishing cotton, of course, is the DMDHEU. And formaldehyde is also found appeal in products used on synthetics to impact the crease retention, anti-static, and other characteristics. I have always said that the chemical industry, the people that make the resins, they've done a tremendous job over the years in the reduction of formaldehyde, because I remember back in the 60s and 70s that formaldehyde release was somewhere up around 3,000 parts per million. So, I mean, you know, it used to be very, very high. I remember going into a clothing store and you could detect it in the air. So They've done a really great job in addressing the issue of formaldehyde release. And of course, today we have a lot of restrictions, not from a legislative standpoint on clothing, but the brands and the retailers, they have set the standards for formaldehyde release that is allowable. And we checked a lot of products, and this was commissioned, but the formaldehyde content, detectable formaldehyde levels, you can see that across the board it's in every product category. Anything from non-denim bottoms, even the jeans, because they use resins to set the jeans for that three-dimensional crease. So we can find formaldehyde in almost any product that's out there. And of course, those are not all 100% cotton. There are blends in there as well. And you can see the age difference there from adults to children. And of course, children, infant wear, the formaldehyde level there is supposed to be 0 in anything that's there.
So Mike, on that chart,
Yeah.
That's the percent of the articles tested.
Percent of the articles tested, yes.
You have the actual formaldehyde levels later on, or how low are we looking at? Less than 100, less than 50? Or?
No, I have to go back and check, but I don't think we have the formaldehyde levels on each one of those. But typically, we go by detectable limits, and those detectable limits now are set. Anything that's 16 or less is considered 0 formaldehyde. So I would imagine that this would be anything within a comfortable range of detection by the methods, which are the ISO and of course the AATCC. So we test those according to standard test methods to give us those
On the
levels.
previous slide, on the inputs, it shows 100% of the garments have formaldehyde. Is that the way you read that?
I'm sorry, which one now?
In the inference, 3 years, up to 3 years, if you look at that,
Greater than 3 years?
Or the infants
No.
to 3 years?
Infants to 3 years.
Infants 2 3 years?
100%.
Yeah, right there, yeah. Bed linen, all cotton.
100% of the items will have detectable.
A lot of those are either pigment pad or pigment print
As,
and the binder. So again, the dimethyl hydroxyethylene, we patented in 1954. It's amazing how many years we've been using that, but it is considered, of course, the workhorse for wrinkle-resistant finishing. And we've done a lot of work, so I just want to share some of the experiments that we've conducted at our facility with regards to scouring after you resin finish. And this is an experiment where we did, of course, no scouring. We finished the bath, and then we scoured it with different, the AATCC standard detergent, surfactant, and then a non-ionic scour. And so you can see there that the experiment with the grams of fabric, the bath volume, and then the amounts of the scouring agent, the bath pH, typically can have a lot to do with how much it's released. The effect of hanging samples, of course, you know they're always in the stores, whether or not they're bagged or hung in the air. And again, you can see there that the proposed limit of 75 ppm. Basically, if it's in a bag, it's going to contain quite a bit more because there's no way for it to escape once it's formed. And this is a buffer DMDHEU, but if it's hung in the air, of course, it is released. And the glycolated DMDHEU, of course, you can see that it's just barely above the detectable limit of 20 ppm. And if it's hung in the air, then it is basically 0 formaldehyde. We've checked a lot of the products that are in the marketplace, and the wrinkle resistant, the best men's shirt in the marketplace right now, we checked that, and it's got about 16 parts per million. Men's wrinkle resistant pant, about 32 parts per million. So, you know, we're at very, very low levels with regards to what we can do with finishing. So to go back to the scour, this is a scour study where no scour, of course, we're up close to 250 parts per million, and we can reduce that with just a simple scour by most any means. Now you're asking yourself, well, after you resin finish the fabric, is the mill really going to go through the processing time, because then you've got an extra drying step, you've got to run it through a scour range. Are they going to bear the expense of doing that? And mills that we've talked to in China and also in Indonesia in particular, they are doing that now. So, you know, it's not unrealistic to expect the mill to after scour whenever they do the resin finish. And again, this is, let me go back, because that's the buffer DMDHEU, which, you know, pretty well known that can give you high. And this is the glycolated. So with the glycolated, I mean, we're really just borderline to begin with whenever we use a glycolated type resin. So scavengers have been used for some time. We had 2 different scavengers that we experimented with and evaluated. They were added to the finished bath. Fabrics were pad dry cured. They were sealed in a plastic bag. And then the crease recovery angle, because you always have to be concerned about, well, I'm going to use a scavenging agent, the scavenging formaldehyde, am I going to impact the efficiency of that resin system? And there's the results. I don't know why that slide is in there. Anyway, the scavenger study showed us with no scavenger, again, we're up close to 225. With the buffered and the glycolated, again, we're just about at about 90, I think. But you see, with no scavenger, each one of those are higher, but by adding the scavenger, we are able to reduce that formaldehyde level down to very acceptable limits with both of those resin types. And then if you look at the crease recovery angle, starting with the buffer DMDHEU, really no effect across the performance using 2 different types of scavenging agents. Of course, the glycolated gave us a little lower crease recovery angle, but again, there's really no effect of using a scavenging agent there. Other blank slides are in there.
So the scavenger agents are included with the finish
With the bath,
during
yeah.
the application?
With the bath, yeah. So that's scavenger A, and then that's scavenger B, with basically the same results, except for this one had more of a negative impact on the crease recovery angle, so we didn't get quite as much cross-linking there. So scavengers, while they can reduce the formaldehyde level, can also interfere with the performance of the resin. So that's just important for people to know if they're going to go that route. And this is scavenger with a scour. And again, if we combine those two, you know, it's an option for a mill to be able to do that and to get very, very low levels of formaldehyde content on the fabric. So after washing, reduces formaldehyde levels significantly, anywhere up to 85% according upon the test. And of course, all of the scours that we use significantly lower the formaldehyde values. So we were able to get well within the specifications set forth by the brands and the retailers. So we just shown that by using what's available to us today, we can get to those low levels of formaldehyde. But we just have to be careful because grease recovery or performance, smoothness, performance can be decreased depending upon which scavenging agent that you use. So to achieve no formaldehyde, combination of scavenger, that particular one that we were using, and an afterwash can be used. We test untreated fabrics with no resin at all, and we get anywhere between 8 and 12 parts per million formaldehyde. So even though there's no resin applied to the fabric, again, just reinforcing that there's really no such thing as zero formaldehyde, because cotton will absorb it from the air. Any questions? Now, is it possible to have wrinkle-resistant finishing with zero formaldehyde? There's been a lot of work done by a major chemical company, and they have a product that is in the market today. It is being used, and it does give you zero formaldehyde or no additional formaldehyde than what the garment or the fabric may pick up in the air. Now, that's commercially available, so yes, it is possible. We've been doing a lot of internal work ourselves and with another chemical company, and we've come up with a couple of systems that do give us zero formaldehyde. It's not quite ready for release yet because we still need to do some additional work, but the way the industry is going and the chemistry that's available to us today from the chemical companies, yes, we can do it.
How is the performance in terms of the wrinkle recovery or the grease retention?
It's as good as the DMDHEU base chemistry that we're using, because we always, whenever we look at a product like that, we always try to get to the standard of what the industry is accustomed to for today. So at first we started out, we said, well, maybe we can get an Easy Care, a 3DP. Then we said, well, yeah, we got there. And then, well, let's try for a 3.5 or 4. And we finally ended up with a combination where we get 3.8 euro press after 5 launderings with no formaldehyde release. Of course, now let's see if we can go a little bit further. But you know, there's always a trade-off. You have to be worried about a couple of things that always come up: in yellowing through some of those products, and strength reduction. And common problems and cost.
But these new products, including the yellowing, the strength, still look good.
Right now, it's still, yes. The commercially available product looks very good, yes. But as Keith pointed out, you know, it does cost a little.
Yes,
But if you're committed, you know, if you're committed and you want, if you want to make a statement that your wrinkle-resistant garment doesn't release formaldehyde, then you know that's what you have to go to. Now, to my knowledge, and maybe someone else knows better, I don't know of any legislation that is coming out where it's going to be, instead of a voluntary type system we have now, that it's going to be regulated from the standpoint of textiles. Anyone have any other insight into that? I don't. I mean, it's on the list. It's on the restricted substance list. It's on the specifications for brands and retailers to have that lower level, which, again, using the chemistry that's available to us today, we can meet all those requirements.
I'm trying to think with the restricted substance list, but then a lot of people go by the OCTEX standard. I think that's 50 or 100 parts per million, maybe, depending.
I think it's 75.
Different articles like you tested there, but fairly acceptable level to work with.
Sure. And again, we can meet that today.
Yeah.
For the longest time, Japan was at 50 parts per million I don't know if they lowered that any further, but
I don't know about Japan. The last time I was in China, there was a real push to lower it to 16. They wanted to get it down to 16. Now, whether or not that has spread throughout the retail brand environment, I haven't any indication of that yet. But if you're going to meet that 16, then you've got to go to the newer chemistry. And there's no secret. I mean, we have basically two structures to work with. It's either DMDHEU or it's DMUG. That's what's available to the market today.
is it driven by, is it the lower level, is it driven by the Western market, or is it really driven or voluntarily accepted by the Asian or Chinese and the other?
I'm not sure where that particular level came from, but I would imagine something like the NGOs. The mills, they know that they're under pressure to lower it. The standards are still coming from the brands and retailers. But like I say, the architects, the blue sign, those type, if you want that kind of a recognition for your garment, then you've got to meet those particular requirements. Gary, do you have a question?
Your use of the term "no" in quotes, saying there's no such thing as no formaldehyde, you run into that in all kinds of sustainable and other environmental things. Some people say, well, we're going to eliminate it, which is impossible, but then there's nothing between that and maybe a government standard. It sounds like there's a need almost for some terminology that is realistic but dependable, because you never know quite what you're getting with these terms. Like you say, there's no such thing as no formaldehyde, but there are some that are really dangerous and some.
Absolutely.
But the terminology really isn't very good in those areas, is it?
Yeah, and the terminology that was used with the Greenpeace, zero discharge of hazardous chemicals.
Right.
Well, it's going to be impossible to get zero discharge. And then you look at it and you say, well, what do you mean by hazardous chemical? There are lists. The AAFA, they have their hazardous substance list that they update usually every 6 months or a year. And most of those chemicals have already been eliminated from textile wet processing. So again, our industry, I think, has taken a really proactive approach to eliminating a lot of that type of hazardous substance. But still, you run across cases where, again, last week I heard a report of PVCs, yeah, in dyes. Now, how does that get in dyes? That's a new one to me. I had not heard that before. But they said that they had a report where that chemical was detected in dyes that they were using. Who knows from some of these countries where they're manufacturing dyes in the garages, who knows what kind of products they're putting in there.
If you look at the strictest definitions of sustainable, it basically says there's no effect on the environment. And that's another thing that is almost never, maybe never achievable. You're always going to have some effect on the environment. But the real question is there a role somebody like some group like AATCC could do in defining those terms, not necessarily setting the specifications, but say a term that is meaningful and adds substance to the discussion and to the labeling of things. Because it seems like that's just a real mess right now.
It is a mess, and there's too many so-called cooks in the kitchen that have entered this arena. We're going to monitor, we're going to make things better, we're going to eliminate all of these chemicals. And the other thing, I think this green chemistry thing is a good springboard for us to take a closer look at and to be very knowledgeable of what, not just the textile industry, because there were people there from Levi, from Vanity Fair, from Patagonia, some of the major brands were there, and they were talking about their concerns for those hazardous chemicals that somehow or another get into the final product, and how do you eliminate those? And so this whole green chemistry movement is going to impact the textile industry without a doubt.